One more time. Uh, when we're talking not only about the territory of Ukraine, for example, Ukraine has more than 80% of territory which are covered with difficult ground conditions. But when we're talking about foreign countries, sometimes we can develop projects in country with more than 80% with difficult ground conditions. Sometimes it's seismicity, sometimes it's volcanoes, sometimes other type of difficult ground conditions. So that is why you have to understand that each ground condition gives you limits to your architectural to your building from architectural point of view. For example, when you are designing building of a big amount of stories, that is impossible to make it look like it is light and flying when you're designing it in the country with the seismicity more than 10 points, because all seismic resistance is connected with additional stiffness elements, and that is why lower floors will be covered with reinforced concrete elements. Yes, there are possible variants like base isolation system, which can reduce the impact of seismic earthquakes. But nevertheless, some difficult ground conditions may will make your building more stiff, or you have to make it a bigger amount of walls or something like that. If you will design building on the seaside of Odessa, you will have to make it stiff enough to withstand the landslides. These buildings will be also the plan of this building will be also covered with special diaphragms of stiffness to make it stiff enough to not tilt under the impact of landslide. So, and today we will start from the classification of difficult ground conditions. We will consider a few of them during this first lecture. But nevertheless, you have to understand that difficult ground conditions are the conditions with which you will have to make a deal during all your architectural practice. Because if architect decide that to withstand the difficult ground condition, it is the structural engineer's business. It's a huge problem for the project. Not some time ago, we have designed building in Cyprus, and architect for that building was also from Ukraine, and that Kiev architect, that architect was from Kiev. So, and he designed that building. He developed the concept of that building, and the site owner decided that he wants to build this building, but our Ukrainian architect didn't take into account that the building is located on the construction site with the seismicity 8 points. And so that led to significant changes of the building. And the problem was that the site owner said, I don't want this building. I don't want this building with diaphragms, etc. I want that building that you have shown me from the very beginning. And it made a lot of fights from our side. We have make this building to look like exactly the same like the first proposed concept from the architect, but it is so expensive. So if the architect have taken into account from the very beginning that this building is located on the territory with the high seismicity, the building had to be changed. But from the very beginning, the site owner would be informed about the consequences of building of erection such a building on his site. So, and step by step, we will consider all difficult ground conditions like undermined territory, subsiding soils, water table uprising, flooding, cars, submersion, abrasion, screes, landslides, rock falls, and also sites with a seismicity of 6 points or higher. It's earthquake engineering. We will consider this the part of this course. By the way, I have almost prepared a course which called earthquake engineering for architects, and I think from maybe from next year it will be available for architects to choose this discipline, but it will be only for the master degree students. So, and first difficult ground condition which we will consider today, it's called undermined territories. Undermined territories and or undermined area is an area that is under the influence of underground mine workings. For example, when we're talking about Donbass, about Donetsk and Lugansk region, those regions are covered with undermined territories because uh, uh, shaft workers mine the coal from those underground shafts, and those emptiness underground has a very huge impact on the above ground located buildings, structures, etc. But when we're talking about Odessa, there is no coal in Odessa, but here we have a lot of underground emptiness, underground caves, which made of shell stone. Do you know what is shell stone? Yes. So, and Odessa is also under the impact of underground of undermined areas. It is covered with underground emptiness of stone. So that is why we have to understand the classification and of those emptiness which are located underground, and also we of those hollow shafts, and also we have to understand what structural solution can we make to make our building ready to withstand such difficult ground condition as, for example, undermined areas. First uh, is about undermining. It's undermining of building structures of pipelines, is an extractions of minerals that affect the objects. And also, no, we will not deeply consider the terms of the building codes. Also, you have also to take into consideration that there is a shift through of the Earth's surface. It's a section of the Earth surface that undergoes displacement under the influence of underground workings. And when we're talking about the undermined areas, undermined territories, we have to take into consideration that there are certain parameters which describes this difficult ground condition, like subsidence in millimeters, its vertical deformation, inclination, because those subsidence may be caused by inclined subsidence of elements, and this inclination is measured in millimeters on one running meter. Curvature, it is once divided on kilometer. Relative horizontal extension or compression strain, and bench height, because sometimes this subsidence could not be from the surface seen not as like one overall curvature, but also can be seen like steps, because the ground sets had non-even sets with such kind of steps. And here is the example of the Odessa undermined areas that are called catacombs. And it's not only the trouble that we have such hollow cores underground, but also the another one problem of our shafts, underground shafts, that they are filled with water. It is also increases the effects of seismic impacts during the earthquake. So, and here are main parameters which describes the which describes the undermined areas. It's like subsidence curves. It's like can be so underground. We have this situation with the emptiness, and that emptiness leads to such kind of curves. Next, it's epures of curves. It's slope epures. It's relative horizontal deformations, because it's not only vertical but also can lead to horizontal deformation, and epures of strike slips. Here are the examples of such undermined areas in Odessa or other regions where people develop coal. Next question that you have to consider today, it is the classification of undermined areas. So we have two types of classification. So first classification, it's connected on four. It's divided on four groups, and each group can be defined according to the relative horizontal deformation, according to inclination, and according to the radius of curvature. And the worst case scenario is the first group of territories. The better solution, the best construction site is without any undermined areas. But if you have a deal with undermined areas, the best case scenario is the fourth category. So worst case scenario is the first category, and best situation with the fourth category. Also, we have another type of classification, and this type of classification is caused by the presence of benches. So, if we don't have such benches or steps during the undermined territories, that's okay. It can be like four K category. But the worst case scenario, if we have benches with a height like 20 from 15 till 25 centimeters. So if we have these benches at the construction site, that's a huge problem for the future building that we will design there. And what do we have to do when we design building on the undermined territory? So first of all, we have to consider various structural systems which we can use there to make a building ready to withstand these impacts. For example, we can use three possible structural solutions. So first of all, it can be rigid, or it can be ductile, or it can be used as a combined design schemes. What does it mean? So it's clear when we have an uneven deformation of the soil, we have to use a rigid building. But if our rigid building has a big length, it's not a better solution to have it make like one solid brick, because if we have long rigid building, uneven deformation will lead to certain cracks and problems in this building. So that is why sometimes it is good to make a combined solution. So first it is rigid, and for example, for existing building, it's better to make such kind of metal belts or reinforced concrete solutions for to make it stronger. And also we can use combined scheme. So, and here is the solution for the combined scheme. When we have one rigid part of the building, so one section, for example, 30 on 80 meters, another solid part, also rigid, which works like one solid element. But in the middle of these two rigid elements, like wagons of the tram uh, or train. So each wagon is really rigid, but the connection between them is ductile. So and in construction, we can use the same solution where we have one rigid part of the building, another rigid part of the building, and this ductile connection. Do you see this connection with the enhancer sliding seam? It makes possible when one part of the building moves from the another to stay in such a position which gives the opportunity to move in the horizontal direction. And this, for example, if this element would be look like this, it will fall down. But if we have extended the contact zone between beam and column, or between slab and beam, in that case, we have additional possibility to move in horizontal or vertical direction without catastrophic progressive collapse. So that is why we can, when we're when we design building on the undermined territories, we can use both rigid and ductile scheme, or combined when we are connecting separate rigid parts of the building with the ductile elements between them. Also, we have to consider another one difficult ground condition, but we will make it on the next lecture. So today, during our first lecture from the second module, we have considered the classification of difficult ground condition. We discussed why is this important for an architect to be informed about the classification and ways of design of building with taking into consideration difficult ground conditions, because difficult ground conditions are really important to be known by an architect, because this is the very important parameter which affects a lot on the architecture of the building, on the form, on the shape of the building, on the shape of windows, etc. And we have already considered first difficult ground condition called undermined territories. Those underground mines can be caused by various works, but nevertheless they can lead to different deformations of the surface of the ground, with curvatures, with benches, etc., and that make us to be informed about this, to know the classification, that the worst scenario is 1 or 1K, and the best scenario when we have under my territories, it is fourth category or 4K category when we're talking about the classification according to the benches at the construction site. And when we are designing on such territory, we can use three main design solutions. It can be rigid scheme, it can be ductile scheme, and it can be combined scheme, which gives an opportunity to connect various rigid parts of the building with the ductile connector between them, so that will make, when our uneven settlements of soils will take place, it will not lead to progressive collapse of the building. We will only see that one part of the building settled down more than the other one, but no catastrophe, no problem, because this uneven deformation was taken by that ductile connection. So, is it clear that part of information that I've explained to you today after the model? Colleagues, can you hear me? Any question? Okay. So, thank you for your feedback. That's all for today. And next lecture, we will continue to discuss difficult ground condition, and we will consider subsiding soil. So thank you. That's all for today. See you next week on the practice. Bye.